My name's Chris Posford. I'm the National Partner Enablement Manager here at Wavelink, and some of you I'm sure I know already. For those of you that don't know me, my job, I guess in one way, is to certainly make sure that you're all comfortable with the technology and know all that you need to know to successfully sell the solutions that we work with you on. And so if you do have any questions going forward, I'm always happy to have a chat, so please feel free to get in touch with me on anything that we're talking about today, and also anything else that we aren't talking about, given obviously that we have quite a wide range of products. So with that, we'll probably just get started. If you do have any questions as we go through the presentation, please type them in the questions box in the panel, which you should be able to see at the upper right hand side of your screen, and we'll certainly go through them at the end of the presentation so everyone can get the benefit of the great questions that you've all asked. Also wanted to mention that the webinar will be recorded and available via Wavelink at the conclusion of the presentation. So certainly if you wanted to have another look down the track, or you may not have sold a DECT solution onto a SIP environment before, and when the time comes you may want to just recap and see what we talked about. So after the presentation there will be an email sent to everybody with details of how you can access that recording. So as the title suggests, the focus today is on the IP capability of the Spectralink DECT 8000 and 2500 systems. They're two of the four Spectralink DECT systems that are available, and the other two, which we're not really talking about, are pure IP based systems, whereas the 8000 and 2500 traditionally have been deployed for analog extensions onto an analog-based PAVX system. So what I wanted to point out today is that these systems do absolutely have the capability to work into a SIP environment, and that's probably a lesser-known thing based on some of the sales that we typically see for these systems. Both the systems that we're talking about today have been available for the best part of 5 years, so some of you will no doubt have deployed one of them or more. Some of you might have done quite a few of them. But again, something that doesn't seem to be all that widely known is that although they are most often deployed on PAVXs via analog extensions and also using the DECT base stations, which use the digital communication between the base station and the server, they do also have the capability to integrate via IP PBX using SIP extensions, and also can be deployed using IP base stations. So just wanted to highlight some details around those specific things today. And whether we're going a full analog deployment or a partial IP deployment or a full IP deployment, all these different things can be done. So let's just learn a little bit about how that can work. So some of the key points we really want to focus on today are the benefits of SIP as compared to analog connectivity. Obviously they're both quite different, and there certainly are some benefits if you go SIP versus analog. Obviously your customer environment will need to support SIP and be set up to cater for SIP, so it may not be the case that we can always deploy SIP, but in some cases where you may have spoken to customers recently, it might be a good fit that there's an option to provide a SIP DECT solution for them. Also want to talk a bit about IP base station compatibility. As we mentioned, these systems are typically deployed with digital base stations, which is the Spectralink DECT base station, but like the IP-based solutions, we can also use IP base stations on these, which does give us a bit more capability for flexibility in deployment. And some of the deployment options that we do have, I mentioned we can go partial or full IP connectivity, so what are the different ways we can break that down. Just to recap, some of you, I'm sure, see these pictures as being very familiar. These are the DECT 2500 and the DECT 8000 systems, which is Spectralink's, two of Spectralink's 4 DECT solutions. So essentially they are one and the same as far as functionality is concerned. It really is just a question of capacity. So obviously I guess we could say that DECT 2500 is the little brother to the DECT 8000, but from a functionality and features point of view, they are one and the same, and even the cards that we use, which is a modular-based system, can be used in either of those two servers. So all the cards that are available can be used in both of those solutions. One of the things we find today is it really is a SIP world. And what we mean by that is SIP is absolutely the industry standard for standards-based VoIP communications, and is supported by pretty much all of the vendors and service providers in the telecommunications industry today. And looking at how that's happened and the way things stand, so that's certainly something that will continue well into the future. Because of that, there's a huge marketplace for SIP systems and services, which gives customers access to a wide range of SIP systems, SIP endpoint devices and services as well, so SIP service providers for SIP trunking, etc. And for resellers, basically what that means is there's a massive potential customer base to sell SIP products into. So there's definitely great opportunities to sell SIP-capable systems like the DECT systems that we're talking about here today. Future-proof is obviously a term that gets thrown around quite a lot, and for good reason. Customers can protect the investment that they've made in SIP-based systems against future upgrades, knowing that they can keep any required components and integrate them into new systems that they may buy in the future. So that could mean, for example, that they might upgrade their existing IP PBX or SIP-capable call server in the future to cater for increased capacity or better features that might come along, and they could still keep their Spectralink DECT 8000 or 2500, knowing that it will happily work with the new server. Another example could be, specifically in the case of these systems we're talking about, if a customer had future plans to move to a SIP environment, they could deploy a Spectralink 8000 today or 2500 using the analog extensions that might fit their existing PABX, and then when the time's right, simply add the SIP capability via a fairly inexpensive interface card that would go into the DECT server and allow it to then connect to the SIP-based call server. And interoperability, I mean, again, SIP being a fairly closed standard, well, it's an open standard, but it's a very tight standard these days. All of the vendors are deploying or creating their SIP stacks following the standard. So basically, I guess also to highlight point 2 there, we get a huge marketplace. So looking at this document here, which is Spectralink's interoperable tested document for their DECT solutions, we can see all the probably common names that we are used to seeing for call servers using SIP. Some of those we probably won't recognise, and likewise there will be additional ones because there's quite a lot of manufacturers that may not be on this list. It doesn't mean they're not certified or doesn't mean they're not compatible. It just means that Spectralink, for whatever reason, haven't specifically done an interoperability test program with them. But you can be sure and confident that if you are deploying onto a SIP-based PBX system, that the Spectralink DECT stuff is a great fit using SIP extension connectivity. How do we do it? Well, this is the card that enables it. This is Spectralink's VoIP interface card. So this is the telephony card we would use when we wanted to, first of all, I guess, in the part we're talking about at the moment, use DECT handsets as SIP extensions of that PABX. Because whether we're using analog extensions or SIP extensions, of course, the DECT handset, even though it is connected to the DECT server, is also an extension of the PABX, which of course gives it its extension number, access to external trunk lines, and all the features that come by the PABX. So here we're using a SIP or VoIP interface card as opposed to an analog card, but it is just the telephony card that we would use. The part number there could come in handy for you if you go to our online store, which hopefully you're all signed up for and accessing at the moment. All you need to do is search for that part number or just browse through the Spectralink DECT products and you'll find that card there. As we said, all the telephony cards between the 8000 and 2500 servers are compatible, so that one definitely is the same card for both server solutions. And this enables 2 capabilities on those servers, and that is the SIP extensions, which we're currently talking about, and also the IP base stations, which we'll talk more about in the next part of the presentation today. Okay, so as far as capacity goes, the VoIP interface card supports 32 simultaneous voice calls. So what we're actually talking about there is, on a SIP call, we actually have a voice stream, which is typically using RTP protocol, and that is the audio component of the VoIP call as it traverses the network there. So for each active call that we have on a DECT handset, that is actually a SIP extension of the PABX, we're using one of the 32 available media resources on that VoIP interface card there. So that's simultaneous call. So if I have one simultaneous call active at any one time, I'm only using one of those 32 media resources, and when the call closes, that resource is returned to the card and available for another handset to use for a call. So just to highlight that, we might have one of our DECT users on a call and they might be talking to someone on a desk phone or an external trunk line. So we really just have one of the DECT phones active. That uses one of the media resources available on that card, so one of the 32. If we were to have an internal call between two DECT users, that would be using two media resources of the 32 available on that card. And if we find ourselves at the point where we have a large number of DECT handsets on the site, and because of the nature of our usage, more than 32 of those handsets will be on a call at any given time, then we can simply add an additional VoIP interface card to increase the call capacity that we have on our system. Okay, so this table here is really illustrating how many calls we can have using the various numbers of VoIP interface cards we might deploy. So I'm just showing up to 4 cards there. That's definitely not a physical limitation. On an 8000, we could certainly have more than 4 VoIP interface cards, although I think you'll find it's very unlikely in any deployment that you'll come across. You'd need more than probably even 2, because again, we're not talking about the number of DECT handsets we can support, it's simply how many of those DECT handsets are on a call at any one time. So if you look at the third row of the table, which is the number of users supported, you see the direct relationship between the number of DECT users and the number of VoIP interface cards. And that's simply because the VoIP interface card, as we said, handles the voice or RTP streams of active DECT calls, but not the SIP registrations themselves. The SIP registrations are actually handled via another part of the DECT server. Okay, so just to recap, you only need more VoIP interface cards if you need to support more than 32 simultaneous voice calls on the DECT phones. So really, again, it's more about how much traffic is going to be active on the system at any one time and not the number of DECT handsets. And obviously that will vary from customer to customer, just depending on their usage scenario. Okay, what are some of the benefits? Well, we're now talking about IP networking. So unlike an analog extension where we actually have to have a physical connection along a wiring between the analog extension card in the DECT server, via typically a punch-down block back into the analog extension card on the PABX itself, which obviously includes wiring and punching down and all that type of stuff. Now we're just talking about complete IP networking. So that makes it a lot easier to add and deploy additional extensions using SIP. And obviously we're using the customer's existing LAN infrastructure, so their LAN switching, their Cat5e, Cat6 cabling infrastructure, which they're typically going to have already in place to support their other IT and networking infrastructure and systems. We're simply tapping into that and utilising that now for our SIP connectivity for our DECT. So yeah, as we said, no wiring or special telephony wiring specifically to support analog extensions. So one of the really nice benefits there that we're hoping to see is a much cleaner environment and easier deployment from the wiring and cabling perspective. So hopefully we're going to go from something looking like that to a much cleaner connectivity point, which is looking more like this. So using the blue cable, same as our printers, same as our computers and servers, we're also now integrating our DECT solution into that. So basically plugging our VoIP interface card as well as our CPU card from our DECT server straight into the network switch, and likewise our SIP capable PABX would also be connected in a similar manner there. Some things to consider when you're going SIP extensions on any of the Spectralink DECT servers, there is a licensing component that needs to be you need to be aware of, and that's whenever you're going to go beyond 30 SIP users, which is 30 DECT handsets connecting as SIP extensions, you need to add a license, which is simply a software license, to enable that. So as a comparison, if we were deploying analog extensions, the number of DECT handsets we can connect to the PAVX via analog is determined by the physical connectivity. So, for example, the 16-port analog card will support 16 DECT handsets connecting as extensions on the PAVX. Once we go to SIP, because it is an IP protocol, we need to add a software license once we go beyond 30 SIP users. So in many cases, 30 is probably going to fall within your customer requirements. But if you need to go beyond that, it's simply a case of adding a software expansion license. So the different, I suppose, breakdowns we can do, or different licenses we can add, if we go beyond 30 users, we just simply add a 150 SIP user license, and then we can go and expand further to 500, 1500, and 4096. So you can see there, we have a massive expansion capability using SIP extensions there. Certainly far beyond what we'd be able to do on analog extensions on the equivalent system. And we just need to be aware that it's a simple software license that we need for that. Another really important requirement, and it may be the case that you're supplying the DECT solution but not necessarily the call server or PAVX, so you'll need to be aware one way or the other, even if that's just to communicate to the partner that puts in the PAVX, that when we use SIP extensions for our DECT phones, each one of those SIP users will also require a SIP license, a SIP user license on the call server or IP PBX. So that whether that's something you need to do yourself because you're also managing that and order those additional licenses, or simply relay to the customer so they can pass on to their PAVX reseller that we're going to also need to have additional SIP licenses on the PAVX or call server to now support our SIP extensions on our DECT solution. And as we said, one per DECT extension. And now, of course, that we're using IP connectivity and IP traffic for our DECT calls, and when they connect back to the PAVX, it's obviously best practice to ensure that we use some sort of quality of service mechanism to ensure that we do have excellent voice quality, because I guess whereas analog is a dedicated circuit between the DECT server and the PAVX, we're now talking about mixing that traffic along their switch network with all types of other IP type traffic that will be also moving through that network. So given that voice is a real-time protocol and users will actually hear any lack of quality of service in terms of might be breakup on the call or just poor quality audio, and that's the sort of things that they might not notice, that sort of loss of quality on a sort of a non-real-time application like surfing the web or doing some email. They're certainly going to notice it using a real-time application like voice. So it certainly is extremely important that when you're running this on an IP network to prioritise your voice traffic over other types of traffic, simply to make sure that we do get excellent voice quality. Okay, so what does it mean in price comparison terms? Because obviously I'm sure your customers are going to be extremely interested in that side of it. So just to provide a little bit of a comparison here, if we look first of all just at the cards themselves, we can see there on the left the 16 analog interface cards. So that would give the capability to connect 16 DECT extensions onto that PAVX via analog, and that's as many as you can connect using that card. We're looking at just a touch over $2,000, and that's MSRP ex-GST pricing at current pricing levels. If we compare that with the VoIP interface card, we're looking at a marginal increase in cost. We're now going up to just a touch under $2,500, but it's definitely worth keeping in mind that whereas we're limited to 16 DECT users on the analog card and also 16 simultaneous DECT calls, once we go to that VoIP card, we actually could have several hundred DECT users as extensions on that PAVX. Of course, if we've provided the user license in addition, and we can also have up to 32 simultaneous calls. So even though it's only a slight increase in price compared to the analog card, it actually does deliver quite a large number of benefits in terms of the capacity supported there. So even if we wanted to have up to 150 users, you can imagine how many cards on the analog side we'd have to add to support that. If we're using a VoIP interface card, a simple software license, at a fairly marginal cost will enable us to have 150 users, and 32 of them could be on a call at any one time. If we put that in a little bit of a scenario to, I suppose, cost it out and expand on that, looking at a 2500 system, which comes with a base station card and a CPU card, and sells for approximately $4,500. Again, that's MSRP ex-GST pricing. And we wanted to put 30 DECT users onto that system. On the analog side, we're going to be looking at two 16-port analog cards. And again, on the IP side, SIP extensions, we're only going to need a single VoIP interface card. So straight away, you can see the cost benefit there of going SIP extensions versus analog extensions. And we've got a significant cost saving, and keeping in mind, once we want to go beyond 30 users on the DECT side, the 2500 server itself actually is going to become too small, because we're going to need our base station interface card. So once we've got that, along with our two analog cards, we've basically filled up the server and we don't have any more card slots to use. If we're going SIP, we could certainly go well beyond 150 or more SIP users using that single card, and also still have our base station card and still have a spare card slot. So not only do we save money on the cards themselves, we might be able to stay on a 2500 server as opposed to an 8000 server. If we look at the next scenario of 100 DECT users or 100 extensions on the DECT server, so we're going to need to go, just to make our comparison, I suppose, realistic in the way it stands with analog, we'll go to an 8000 server. So if we look at the cost of that, comes with a CPU card, we're looking at roughly around $2,900. Now for 100 extensions, we're going to need 7 16-port analog cards, if I've done my maths right there, simply because, again, we can only have 16 DECT users per card. But if we were to go to the VoIP interface card, we could have a single card to support that, because, again, the SIP extension registration is not handled by the card, simply it's the voice streams, and then we'd simply add our expansion user license to take it from 30 to 150 users. And we'd have our base station card for either scenario there to support our digital base stations. And you can see there that there is a massive cost difference in that scenario using SIP extensions as compared to analog extensions. Now, I guess as resellers, obviously the more hardware you sell, obviously that works out better for you guys, but this may unlock customer opportunities that were simply not there before, because the cost for the customer to deploy a system like this was too great. So this could, I guess, open up new avenues for sales that may not be available via analog. So I guess the key thing is it's great to have an option. If you do have the option to go analog or SIP, you can work it out from there. Okay, so that's really the first part of the presentation around SIP extensions. So the second part of the presentation that I wanted to talk about now is IP base stations. So as I said at the start of the presentation, IP base stations are what we would use historically on the IP DECT servers, the 400 if we needed to expand that, and also the 6500, which are the pure IP DECT systems. But as of recent times, we can also use these on the 2500 and 8000 servers as well. So we have the choice. We could use the digital base stations, which most of you would have deployed historically, and we also now have the option as well to deploy IP base stations. One of the differences between the digital and the IP base stations straight away is that the IP base stations can actually support 11 voice channels per base, and that compares with either 4 or 8 channels, depending on which model you go for, on the digital base station. So if you're deploying into a high volume or a high call volume customer environment, then there is straight away there's a benefit for using the IP base station. What that could mean is, in a high volume area, say for example a nurse's station at a aged care facility or a hospital, instead of having to deploy maybe 2 digital base stations just to give us the capacity, we might be able to now just use a single base station if we use an IP base station. These are PoE enabled, so like I guess a lot of devices these days, it's a great thing if we can just power those straight off our switch. Makes it nice and simple. Takes away things like plug packs, which often are the first point of failure in an endpoint device, and just keeps the cabling all neat and tidy. So these things are certainly PoE enabled. And what you can also do is support an external antenna for extended coverage. So this is probably not the norm, but if you did have an area where you needed to, I guess, send signal a long way, but you couldn't get any wiring or cabling in to put base stations in the interim, then you could add an additional or add an external antenna here, and that would allow you to throw that signal a long way in a direction. And so that may have sort of relevance for certain customer scenarios that you might have. Another really nice thing here is the deployment. I guess from one point of view, if you go a digital DECT base station, you need to have, a bit like the analog extension, you need to have all the wiring done, dedicated pair to the location where that base station will reside. Here, again, using IP networking, we simply plug that into our data network via our switch, our PoE switch, and we can then have the server auto-discover that base station over the network. And so for the administrator who's actually deploying these, when they're putting their base stations in, very simple matter, plug it in, mount it where it needs to go, and then just via the DECT server admin interface, we can easily discover that and also configure it. And that also means if we're adding new areas to an existing facility or maybe bridging some coverage gaps, again, that's a much quicker and easier way to do that. And also is going to reduce the cost of your cabling because we're simply using customers' existing LAN. So again, looking back to those pictures we had earlier on about the wiring as compared to using IP networking, we're also going to end up with a much neater looking solution there. And as I already said, much easier to deploy and add more bases as we need. So if we look at it overall from the base station perspective now on these systems, what we could do, and I guess what we've always been able to do, is have our DECT base stations, and again that's where the base station is physically wired to the base station interface card in the server and powered via that. Or now we could also alternatively use IP base stations, so plugging everything into the LAN and PoE powered base stations and giving us a lot more flexibility to deploy. Or we could even have a combination of those bases. So if we had, let's say a nursing home, again, good example is to go into nursing homes, and maybe they were opening a new wing on the same facility or same site, and we might have used digital base stations to that point in the existing part of the facility. These days everything typically is cabled for IP connectivity, so we can just say, we need to have base stations here, here, and here in the new facility, and simply run Cat5e points to those places and deploy IP base stations in that new part of the building. So we can have a mixture of IP base stations and digital base stations as well. This is something else that we unlock the capability to do if we use IP base stations on these servers. We basically open the possibility of deploying a multi-site solution using a DECT server at one site. So let's say the main site or the head office, and then just deploying IP base stations at branch offices to support local DECT users. So that could work really well for businesses where they have small branch offices with a small number of DECT users at each of those sites, and just deploying the IP base stations. That's not going to work for every solution and scenario. If we're using things like application servers, might be a nurse call environment, then typically we're going to deploy a DECT server at each of the locations rather than doing this multi-site option. But there may be some customer solutions or scenarios out there where this is definitely going to be relevant. Okay, so just jumping back to the price comparison again, and if we look on the left, we've got the base station interface card. That card supports up to 8 digital base stations. That's the maximum limit we can put on there, and that retails for about a bit over $1,300. If we then look at the VoIP card, and the VoIP card is, again, like with these SIP extensions, this is what enables IP base station connectivity. We're looking at just shy of $2,500. The difference here again is the base station interface card physically limits the number of base stations we could connect, whereas like the SIP extensions, the VoIP interface card doesn't impose a physical limit on how many IP base stations we could use. So we could certainly go well beyond 8 IP base stations using a single VoIP card. So from that perspective, it may work out to be significantly cheaper if we're deploying multiple cards, or if we'd have to deploy multiple cards for the base station interface card comparison. This should look quite familiar. So just jumping back, I guess, to this scenario, which was what we looked at earlier, all we've really got different here is now we've removed the base station interface card requirement from the right-hand side, because if we're deploying SIP extensions alongside IP base stations, then we can do both of those things via our media resource card. Or sorry, I should call it the VoIP interface card. So that's something now has even increased the cost difference from going a full analog extension solution using digital base stations to just going a completely IP solution on the DECT side. So huge cost difference there. In that scenario there, I guess we could have up to 16 of the DECT SIP extensions connected at any one time on a phone call. And the reason for that is, I'll cover it here, but so as I said, we need to have the VoIP interface card in the DECT server if we want to use IP base stations. So if we look back to our little scenario of media resources before, when we talked about this earlier, we had one media resource for that scenario, and that was because we were assuming we're using a digital base station. But if we use IP base stations, any call that is active on an IP base station will also use one media resource. So even though we've only got one DECT handset here, we're assuming it's connected via an IP base station, so it's using one media resource for the SIP call, or the RTP component of the active call, and it's using one media resource for the base station that is running that call. So we need to be aware that we do increase our requirement for media resources if we're using IP base stations alongside with SIP extensions. So that may well mean, rather than using a single VoIP interface card, depending on our scenario, we might also increase that to 2 if we're also using IP base stations there. Another consideration which is important, if we're deploying IP base stations, we're typically going to need to have a greater overlap between base stations. So if we've got multiple base stations in a customer's environment, we typically need to put them a little bit closer together as compared to DECT digital base stations. And that's simply because the IP base stations synchronize with each other over the air using their radios, compared to the digital base stations which do it all over the wire. So for like customer environment, you might find that you do have to deploy additional IP base stations, probably not a lot, but marginally more, to provide the same level of coverage for the DECT handset. So just something to keep in mind. That's something we can help you with. If you're not sure, you know, the numbers of base stations that you use for an IP base station environment as compared to DECT, as compared to digital. If you're much more used to doing digital, just give us a call and we can certainly explain all that to you. So it's not a huge point, but it's certainly an important one. We can add more information as required to that. This is a matrix of the 4 DECT server models. I've grayed out the IP ones because we're not really focusing on them today, but just very quickly, you can see if we look on the second last line there, which is the number of DECT handsets we can subscribe to each system, the first column being analog and the second column being VoIP, we can see that we can go from 32 DECT extensions on a 2500 using analog right up to 150 on the 2500, and likewise we can have almost 4 times, in fact we can have over 4 times the number of DECT extensions on an 8000 if we use a VoIP interface card as compared to the analog card. So it does allow us to deploy a much larger number of handsets, but probably more importantly, since it's unlikely anyone's going to go probably even to 1000 DECT users, it's doing that with a much reduced number of cards, so you get basically getting more for less. Okay, so that's most of the information I wanted to deliver. Just to recap on some important points there, we now can fully support IP connectivity on the 8000 2500, and as we said, we can also have partial IP connectivity, whether we're using IP base stations and analog extensions or SIP extensions and the more traditional digital base station. We can basically slice and dice that any which way we want based on the customer scenario and budget. We're definitely going to get improved deployment flexibility because now, based on the type of cabling or wiring infrastructure the customer has, and the type of extensions that their call server supports. We can pretty much fit in with any of that, and that gives us our deployment flexibility. And hopefully, if we're going to do it a full IP solution, we can, I guess, have a much simpler and neater way to cable it all together as compared to analog and digital base stations. And as I just said, we certainly increase our capacity, and more importantly, we can do that with less infrastructure. So potentially a lot less cost for the customer to purchase a system, and great capacity for adding a lot of users and base stations if we need to. Just really quickly, we've got a couple of promotions on at the moment. I realise it is late in the year, so these things do finish on the 31st of December, so I'm not sure if there's really a great opportunity. But if you go to our website, you'll see, and our web store, you'll actually see some promotions that are available. So there's the Avaya one, which basically gives you 20% discount on any new Spectralink DECT handsets, which are purchased for an upgrade from an old Avaya or Nortel DECT handsets. If you have a customer that runs those Avaya or Nortel DECT handsets, you can, I suppose, get some new Spectralink DECT handsets for 20% discount. And if you were to purchase any infrastructure for the DECT solution at the same time, you will also get that 20% discount applying. So there's the link for that one. If you go to our online store, you'll also find that there's a Cisco one as well. Simply go to the online store, and on the home page you'll see a banner with promos, and you can click on that to find more information. So what I'd like to do now is well, first of all, I guess we can look at any questions that were typed into the question box during the webinar. So I'm just going to invite Kim Bender, who's our marketing consultant, to unmute herself, and if we do have any questions there, just read those out and we can answer those.
Great, thanks Chris. Look, it doesn't appear that we've had any questions come through, so just a reminder, if you do have any questions, just enter them into the questions box, and Chris will answer those here now during the webinar.
Fantastic, thanks Kim. I'm going to take that to mean that I've done a reasonably good job of explaining all the ins and outs of going to an IP-based DECT 8000 or 2500. If you do have any questions, we'd love to talk to you, so please feel free to contact us here's our main dialing number there, or email us. We're certainly happy always to help you with any queries that you have. If you need some pre-sale support, you've got a customer opportunity and you're sort of now realizing, okay, maybe SIP extensions or IP base stations or both is a valid solution for them, or you're wondering if it might be, by all means we can certainly help you with that and explain any of the ins and outs of anything we've covered today. So just finally, I'd like to certainly thank you all for giving up your time and attending the webinar. It's something we'd like to do more of, and so if you do have any topics that you feel might be relevant, we can certainly take that on board. And as we've said, the webinar has been recorded and will be available, and that will be provided to you via an email, or at least the information for where you can get a copy of that later on today. So thanks very much to everyone for attending, and from everyone at Wavelink, we'd like to wish you a Merry Christmas and Happy Holiday period, and look forward to speaking to you again in 2015. Thank you.